Alright, fellow classmates, I'm a little late getting my posting in, so it looks like everybody took section 17.2, 2 through 5, so I figured that I would do one. I hope nobody struggled with this one because it was fairly easy, but in the event that somebody did, I hope that this example will explain it for him. So 17.2 covers non-homogeneous linear equations, whereas 17.1 was pretty easy and it just went over second order linear equations. So number 1 is the non-homogeneous equation y double prime plus 2y prime minus 8y equals 40. So the first thing that we want to do is solve the complementary solution, or y of c. Now to do this, we're just going to do what we did in 17.1 to solve those second order linear equations. So we're going to use r squared plus 2r, because we have the 2 here and a 1 here, minus 8 equals 0. Set that equal to 0. Now all that we have to do is factor this, and it factored pretty nicely. And I got r plus 4 times r minus 2 equals 0. Therefore, r is equal to negative 4, or r is equal to 2. So now we're just going to put our complementary solution together, y of c, which is the general solution associated to, or is the general solution to the associated homogeneous equation. So we have y of c is equal to c1, which is a constant, times e to the negative 4x, plus c2, or a second constant, times e to the 2x. So we can't just stop there because that's just our complementary equation. According to theorem number 7, the general solution y is equal to y of x to the non-homogeneous differential equation in the form of y is equal to y of c plus y of p, where y of p is any particular solution to the homogeneous equation. So what we need to do is we need to solve this y of p. So y of p deals with this little section over here, 40, which as the book refers to it as g of x. So any non-homogeneous equation is usually in the form of a y double prime plus b y prime plus cy is equal to g of x. So in this example, our g of x is simply 40, which makes this a fairly easy problem to solve. So we know that our y of p is actually just a constant. So the y prime of p is equal to 0, and the second derivative of y is equal to 0 as well, because the derivative of constant is 0 and the derivative of 0 is 0. So what we need to do next is we need to plug that back into the first part of our equation here, the y double prime plus 2y prime minus 8y. So I plug in y double prime equals to 0 plus 2 times y prime, which is 0, minus 8 times c equals 40. And now all I have to do is solve for c. We only have one variable in this equation, which makes it nice and easy to do, because these two simply go to 0. 0, 0. 0 plus 0 is 0, minus 8c equals 40. So we have negative 8c equals 40. We're just going to divide the 8 out to get c alone, and c is equal to negative 5. Therefore, y of p is equal to c, and since c is equal to negative 5, y of p is also equal to negative 5. So if we plug that back into the equation from theorem number 7 right here out of 17.2, we have that our general solution is equal to c1 e to the negative 4x plus c2 e to the 2x minus 5. So I know that this one was fairly easy, and the other 4 problems in this section were a little bit more extensive, but really all those come down to is basically following these same steps, where you're going to solve for the complementary equation, and then you're going to solve for the particular solution, add those two together to get our general solution. The other problems in this section basically hinder on algebra. It's doing lots of algebra. I know that I think 3 and 4 use the product rule for derivatives, so that's another application there as well that we're going to have to deal with. But otherwise, number 1 is a great example, just kind of going over the basics. And I hope that I explained everything well for you guys, and have a great week.